In this video, we are going to study some counting techniques. In a previous example, we studied a case when we toss a coin and throw a die. How many possible outcomes, how many possible results can we obtain when we do this procedure? When we toss a coin, we can obtain head or tail. When we throw a die, we can obtain 6 possible results for each outcome of the coin. The list of all outcomes are head 1, head 2, and so on, and T1, T2 until T6. In total, we have 12 possible outcomes when we toss a coin and throw a die. The fundamental counting rule states that if we have 2 events that occur in sequence, if the first event occurs in 2 different ways and the second event can occur in 6 different ways, the number of ways that these 2 events can occur simultaneously is given by 2 times 6 equal 12 different ways. That is the fundamental counting rule. If we have 3 events that occur in this sequence and the first event can occur in 3 different ways, the second can occur in 4 different ways, and the last one can occur in 2 different ways, then the number of ways that these 3 events can occur is given by 3 times 4 times 2 equal 24 different ways. We can do a tree diagram to obtain the number of ways that these 3 events can occur using a tree diagram like this, but it's a little more difficult in this case, and not in all cases we can do a tree diagram because in some cases it's impossible. In those difficult cases, the fundamental counting rule is very useful. Let's study other techniques that are obtained from the fundamental counting rule. The first one is permutation. When we have n items, all of them distinct, and we want to select r items without replacement but ordered matter, then we have 1 permutation. If we want to count the number of permutations that we can obtain from n items, the formula is given by this. This is the notation and the formula. From n item, we are going to select r item but ordered matter. Then the formula is n factorial divided by n minus r factorial. For example, from 5 letters, in how many ways can we select 3 letters from this 5 letters but order matter? If we apply the formula, we have from 5 items, we are going to select 3 items but order matter. Then the formula is 5 factorial divided by 5 minus 3 factorial. Then if we compute that, we have 5 times 4 times 3 times 2 times 1. This is 5 factorial divided by 5 minus 3 is 2 factorial, which is 2 times 1. Then we can simplify canceling this factor and we can obtain 5 times 4 times 3, which is equal 60. In 60 different ways we can select 3 letters from 5 letters but order matter. For example, one permutation could be A, C, E. Another permutation could be the same 3 letters but in this order, E, A, C. Different permutation. But we can obtain 60 different 3 letters from these 5 letters when order matter. This formula was obtained from the fundamental counting rule. Let's verify it. We want to select 3 letters but order matter. The first selection, the second selection, and the third selection. We have 5 different letters. We are going to select 3 letters and without replacement. If we have 5 letters, in how many ways can we fill the first position? Obvious is 5 different ways. In how many ways can we fill the second position without replacement? We took already 1, then we have 4 letters to fill the second position, and we have taken 2. Then we have from these 5 letters, we have taken 2. We have 3 letters to fill the third position. Then we have 3 events which occur in this sequence. Then if we apply the fundamental counting rule, the number of ways that we can fill these 3 positions is given by the number of ways that we can fill the first position times the number of ways that we can fill the second position times the number of ways that we can fill the third position. If we multiply these 3 numbers, we are going to obtain 60. If we want to use the factorial notation, we can observe here that 5 times 4 times 3, we can complete 5 factorial multiplying by 2 times 1. If we don't want to affect the answer 60, we need to divide this answer also also by 2 times 1. Then in the numerator we have 5 factorial, and in the denominator we have 2 factorial, and 2 was obtained from 5 items minus 3 items that we selected. 5 minus 3. That is the formula to obtain from 5 items 3 items when order matters. Let's find a formula to count combination. That is most important in a statistic, because we have n items, could be the population. We are going to select from this n item r items, but order really doesn't matter. The notation and the formula are this. From n item we are going to select r item, but order doesn't matter. And the formula is similar to the permutation, is n factorial n minus r factorial r factorial. The formula for permutation is given by n factorial divided by n minus r factorial. You can observe that the combination formula includes the permutation formula. We can state that the combination is equal the number of permutation divided by r factorial, which implies that if we have n item and we select r item, if we count the number of permutation and combination, we observe that the number of combination is smaller than the number of permutation, because we obtain the number of combination dividing the number of permutation by this number r factorial. If we have a population of n items, we can select this number of sample with size r. This is only one sample, but we can obtain a lot of sample of the same size, and this number of sample of the same size is given by this operation. In a sample, really order doesn't matter. If you want to count the number of permutation when you have all sample when order doesn't matter, you have to multiply the number of combination times r factorial. In this combination with r item, if we want to order those r items from r items, we want to order r items, then if we apply the formula for permutation for r item, we have r factorial divided by r minus r factorial, then this is equal r factorial divided by 0 factorial. By definition, 0 factorial is equal 1, then this is equal r factorial. Then for each combination we have r factorial permutation. Then when we multiply the total of combination by r, we can obtain the total number of permutation. Let's do one example. If we have 5 letters, but from these 5 letters we want to select 3 letters, but order doesn't matter. We have 5 letters and we want to select 3, but order doesn't matter. The notation is from 5 items we want to select 3 items, order doesn't matter. The formula for combination is 5 factorial divided by 5 minus 3 factorial times 3 factorial. Then in this case, if we expand, the factorial is 5 times 4 times 3 times 2 times 1 divided by 5 minus 3 is 2 factorial times 1 times 3 factorial. 3 times 2 times 1. Then we can simplify this 3 factorial with this 3 factorial, this 2 with this 2 in 4, and we have 10 different ways. We can select 3 letters from 5 letters when order doesn't matter in 10 different ways. To refresh the factorial operation, n factorial is obtained when we multiply m times n minus 1 times n minus 2, so on until times 3 times 2 times 1. For example, 5 factorial is 5 times 4 times 3 times 2 times 1 equal 20, 60, 120. 2 factorial is equal to times 1. 1 factorial is equal 1. By definition, 0 factorial is also equal 1. The result of factorial operation involve big number. For example, if we have n items and we want to select from this n item 3 items, in how many ways can we select 3 items from 100 items? Then when order matter, let's count permutation. From 100 items, let's select 3 items when order matter. Then that is equal 100 factorial divided by 100 minus 3 factorial. Then 100 is equivalent to 100 times 99 times 98 times 97. Let's stop here because we have to continue times 96 times 95, but in the denominator we have 97. 97 factorial is 97 times 96. And here we stop in this point because we can cancel this factor with all of these factors. Then the result is obtained by multiplying only these three numbers. That is some trick to obtain the answer very fast. Also, you can find this operation in any calculator. The key is NPR and the key for combination is NCR. Then you need to input 100 and you need to press this key to find the number of permutation. Then you need to press in this sequence 100, this key, 3 equal, and you will obtain the answer immediately, which is equal 970,200. You can obtain this answer multiplying these three numbers or using calculator in this way.